So in my last video, I mentioned that you can do stoichiometry where the answer doesn't always have to end in moles or grams. Sometimes it can end in milliliters, and that milliliters can be for a solution in liquid form, or it can be for a gas. Now, there's a really neat relationship that exists at what's called STP. Now, STP stands for standard temperature and pressure. STP, standard temperature and pressure. And standard temperature is equal to 0 degrees Celsius, which is 273 Kelvin. And standard pressure is 1 atmosphere of pressure. It can also be 101.3 kPa, 760 millimeters of mercury, or 760 torr. So those are all the different pressures. Those are different pressure units, but they are all the same value. And so that's what standard temperature and pressure is. When you're at these conditions, there's a really unique relationship that exists. If I were to take 1 mole of any gas when it's at STP, okay, 1 mole of gas at STP, and this is any gas whatsoever, a mixture of gases, a pure gas, whatever. 1 mole of gas at STP will occupy 22.4 liters of volume, or 22.4 decimeters cubed, because a decimeter cubed and a liter are the same thing. So this is that really cool relationship that exists, and this is what's going to help you solve some more stoichiometry problems. So let's do 2 examples in this video. The first is, how many milliliters of hydrogen are produced if 4 grams of zinc react with excess hydrochloric acid? So go back to your stoichiometry steps. The first thing that you have to do is write a balanced chemical equation. It's never going away. Just get used to it. Okay? So we have hydrogen plus, hydrogen's one of our products. It says hydrogen is produced. Let's read this again. We have zinc reacts with hydrochloric acid, HCl, to produce. We know that hydrogen is one of our products, and this is a single replacement reaction, so our other product is going to be zinc chloride, and we have to remember to balance our charges. Okay? And so now we balance our equation by putting a 2 there. Let's go ahead and take a look at our problem. We're starting with 4 grams of zinc, so we're right here in the reaction, and we want to get to milliliters of hydrogen, H2. So first step, convert those grams of zinc to moles by using the molar mass. Molar mass of zinc is 65.4 grams of zinc. Okay, and yes, I have a lot of the periodic table memorized from years and years of chemistry, but I still keep it handy because sometimes I have to double check. So you should keep yours handy too whenever you're doing problems as well. Okay? And now I'm going to convert from moles of zinc to moles of H2. And I'm going to use the coefficients in my balanced equation to do that. Okay, so it's a 1-to-1 ratio. Now, here's the step that's different from the last set of problems that I did as examples. Last time, we would have taken those moles of H2 and gone to grams. We're not going to do that this time. Check out your mole roadmap. You can go from moles of something to gas, to milliliters of a gas or volume of gas at STP, and that's what we're going to use here. So I'm going to use that relationship that I gave you, that 1 mole of any gas at STP, because up here it says assume all reactions take place at STP, is equal to 22.4 liters. Now, the question asked me how many milliliters, so now I have to convert milliliters or liters to milliliters, but that's probably the easiest step of the whole problem. So 1 liter is 1,000 milliliters. And I get my answer to be 1,370 milliliters of H2. Okay? Realize I'm using proper sig figs, so my answer might be rounded a little bit different than yours, and that's okay. All right? Let's try another one. So this time, if excess chlorine gas reacts with a solution containing 20.0 grams of potassium bromide, how many cubic centimeters of bromine gas are produced? So again, first step, write a balanced reaction. So chlorine gas is reacting this time, so I can write that down. And it's reacting with potassium bromide. So again, we have a single replacement reaction. And that's going to form potassium chloride and bromine gas. And I need to balance my equation. Notice both chlorine and bromine, when they're by themselves, are diatomic. So have to remember that. There's 7 elements that you have to remember that for. And I used to teach kids FHN broccoli. Those are your 7 diatomic elements: fluorine, hydrogen, nitrogen, bromine, oxygen, chlorine, iodine. So if you're having a hard time remembering FHN broccoli. Okay? Now, let's do our problem. We start with 20 grams of potassium bromide, and we want to know cubic centimeters of bromine gas. Typically at room temperature, bromine is a liquid, but it can be in the gas form if you're a little higher up in temperature. So we could get bromine gas in this case. So 20 grams of potassium bromide. Convert it to moles. Always convert that given to moles if it's not already there. So, molar mass of potassium bromide is 119.0 grams per mole. Now, I want to go from moles of potassium bromide to moles of bromine. So I'm going to use the coefficients from my balanced equation to do that. Okay. And now again, I have to check and see what units do I need that bromine to be in. And I need it to be cubic centimeters, or centimeters cubed. Okay? Centimeters cubed is the same thing as milliliter. So I'm going to do my moles to volume conversion again at STP. 1 mole of any gas is 22.4. I'm going to use decimeters cubed this time. Okay? And then I'm going to convert to centimeters cubed, and 1 decimeter cubed is 1,000 centimeters cubed. And my answer is 1,880 centimeters cubed of bromine gas. Hey, 2. Stick that 2 on that BR. There we go. Questions? Let me know.